Hi, and welcome to the DACC Engineering Pathway for Robotics, Automation, and Design. My name's Mr. Paisley. I'm the instructor for this program, and if you find that this information is something that you would like to learn more about, by all means, my contact information is right here. Feel free to reach out via email or phone, and I would be happy to give you more information. So what you're seeing here are some images of this brand new pathway. This is a 2-year pathway for juniors and seniors. And in this slideshow, I'm just going to give you a basic overview of what the program is, and then also talk about student opportunities that we have in regards to industrial certifications, college credit that you might be able to earn while you're still in high school, career and college exploration opportunities, give you a student testimony of what a typical student is experiencing here in my program, as well as just some next steps if you are interested in possibly applying. So the Robotics, Automation, and Design program, it's a brand new pathway, and we've been very intentional about why we've designed what we've designed. And basically, just like it says here on the slide, industry is rapidly advancing, and our future engineers and technologists and technicians, they need skills to navigate inside of what we're calling Industry 4.0. It's an era that we're currently already in, and it's defined by things like additive manufacturing. So think like 3D printing, robotics, autonomous equipment, and the Internet of Things, right? Components that can basically talk to each other, save data in the cloud, pull that data down, and respond in real time, develop lean manufacturing techniques, so on and so forth. There's a lot changing right now. And it requires a very specific skill set. So that's why we've designed this pathway. So the Robotics, Automation, and Design pathway, or you might hear it referred to as RAD, has been created to combine areas such as CAD and 3D design with electronics and robotics and controls, and bringing them all together to equip students with skills needed to help bring industry into this next phase of automation. I do want to stress this program is academically rigorous. Students should definitely be prepared for a highly technical and highly collaborative experience. I recommend strong skills in mechanical aptitude, science, math, as well as group collaboration. So please keep that in mind. Again, this is a 2-year program in the 11th and 12th grade. So what's it look like? In the 11th grade for your junior year, we take 2 courses. One is engineering design, the other is DC circuits. Engineering design is teaching an engineering design process, getting you students to think like engineers, to follow a formal process for problem solving, as well as working through projects. Speaking of projects, we learn a lot about basic production and process design. We do all of our CAD and 3D modeling curriculum mostly in the junior year. And we're going to work on things like SolidWorks, AutoCAD, Autodesk Inventor. Those are the primary programs that they use in industry for CAD and 3D modeling. So that's what we use in the lab. This is certification driven, and we'll talk about that here in a few slides. Junior year is also electrical. So the course is called DC circuits. DC is direct current. So we learn DC theory, DC circuit analysis. We learn all about electrical components and how we can use those to manipulate circuits. We also learn a little bit about AC, okay, alternating current. We learn some digital electronics in the junior year, and we also tie a lot of this back to OSHA 10 safety training. So what's the 11th grade look like? Here's a few images. In the upper right corner, you can see a student working on SolidWorks. So he's doing a lab there where he's designing a candlestick holder. You can see Vex Robotics down at the bottom. Vex is a great primer to learn just the basics about robotics and electronics. And we use this sometimes just for little mini design challenges in the lab. On the top of the slide, you can see a student working on one of my AC/DC trainers, where there are real-world components that he's wiring together into a circuit, and then he's using a multimeter to troubleshoot that circuit as well. So that is great hands-on practice. And then what can I say? On the left, we do fun stuff in the lab too. It's not always serious. So here's a day in the life in the electrical lab. We have fun. All right, so that's the junior year. How about senior year? So senior year, 2 more courses, robotics and engineering logic. Now, with robotics, it's not the VEX robots that you saw in the last slide. It's going to be real-world industrial robotics on the FANUC and the Yaskawa Motoman platform. Those are 2 of probably the top 5 robot companies in the world. We'll learn basic material handling on those robots, but we'll also layer that and go the next step and go into robotic vision. So what happens if we strap a camera to these robots? Now the camera almost has gives it a primitive artificial intelligence where the robot can now respond to what it sees in front of it in real time. We also learn about offline virtual programming, which is a skill that is in demand in industry right now. And again, very much certification driven. Senior year is also the engineering logic coursework. This is where we do all of our controls training. So think PLCs. PLCs are programmable logic controllers. They're basically mini computers, and they are the things that coordinate automated equipment. So maybe we have multiple robots that work side by side on a part, and they're kind of dancing around each other and doing jobs at the same time. Well, how do they know when to go or where to go? Those PLCs are what's directing the traffic to multiple robots or to conveyor systems and so on and so forth. Again, another high demand skill out there in industry right now for engineers. So we learn all about PLCs, building them from the ground up, learning components, learning the ladder logic to program them, how to wire them, and then building all this together in different projects. We do more digital electronics. We'll work with Arduino kits in the senior year. So fun year between the robotics and then the controls training. Again, images of what you can expect in the 12th grade. You can see pictures of my students. Very proud. They just received their Yaskawa Motoman certifications there in the corner. You can see a close-up shot of the Yaskawa Motoman robot in the lower right. In the middle of the screen, you can see the FANUC robot that has vision on it. So that is able to see what's in front of it. So we have a conveyor set up with parts moving down the line, and that robot can pick up the parts and move them as they come. And then those PLCs that I mentioned, on the left-hand side of the slide, you can see pictures of some of the PLCs that we will be working with. Those are some, not all of the PLCs. So here's one way that DACC is very different from most high schools. And I keep mentioning certifications. And I'm not going to go through all of this for the sake of time, but you can see there are at least 7 individual certifications that you have the opportunity to earn in these 2 years. Possibly an additional 3 that we're looking to expand into here, maybe as early as next year. So lots and lots of certifications. You can walk out with maybe a whole fistful of certifications before you get out of high school. On top of that, we're working on implementing college credit for your time here at DACC. We're doing this through a thing called a C-tag. It's basically just an articulated college credit. And I am fairly confident that we will have C-tags for all 4 of the courses that our students take throughout the 2 years in this program. This is currently under development, but stay tuned. I am pretty confident that we're going to be able to offer multiple college credits for this program that we're doing. Speaking of colleges, lots of our students coming out of our engineering programs are going on to college, and you can see they are all over the state and continuing to spread out even throughout the region now, as well as the military. So you can see in the corner there, I listed the military because we've had several graduates transition into several different STEM-related specialties in the military, and that has also been a great segue from our program here at DACC. In closing, I just want to highlight one of our current seniors. This is Tarun. Tarun comes to us from Olentangy Liberty. I first met Tarun when he came over from Liberty. He was going half day also to the Olentangy STEM Academy during his freshman and sophomore years. He took a couple engineering classes there, and that's where he kind of got interested in learning more here at DACC. Once he got here to DACC, he took a special liking to the robots in particular, and this kind of helped him solidify his career choice. And what he's doing now is planning to move on to college, get a bachelor's degree, become a mechanical engineer, and wants to stay close to home and work at Honda in Marysville. After seeing more about Honda, he noticed that Honda is just full of those Fanuc and Yaskawa Motoman robots that we use in the lab, and that's what he wants to do for a career. So he is currently applying to all of the top colleges in the state, and I have no doubt Tarun is going to be very successful as he moves on from DACC. So he's just one of many stories like this in the program. The testimony in his own words are in our virtual tour online, and I suggest that if you haven't checked that out yet, get online and check out our lab in 360 and do that virtual tour. You'll see more there. So in closing, go to our website, check out the lab, get more information. If you want to apply, all of that information is at our website as well at delawareareacc.org. We're also on social media, as you can see on this slide. Check us out. Reach out to me if you'd like more information. Again, my contact info was at the front of this slideshow. Thanks for watching.